Hi friends, I'm Sampath of Mechanical Bay, roll number 17241803663, and I'm here to tell you all about the alloys. An alloy is a combination of metals or of a metal and another element. Alloys are defined by a metallic bonding character. An alloy may be solid solution of metal elements or a mixture of metallic phases. Intermetallic compounds are alloys with a defined stoichiometry and crystal structure. Zintal phases are also sometimes considered alloys depending on bond types. Alloys are used in a wide variety of applications. In some cases, a combination of metals may reduce the overall cost and the material while preserving important properties. In other cases, the combination of metals imparts synergetic properties to the constituent metal elements such as corrosion resistance or mechanical strength. Example of alloys are steel, solder, brass, pewter, duralumin, bronze, and amalgams. The alloy constituents are usually measured by mass percentage of particle applications and in atomic fraction for basic science studies. Alloys are usually classified as substitutional or interstitial alloys, depending on the atomic arrangement that forms the alloy. They can be further classified as homogeneous or heterogeneous or intermetallic. An alloy is a mixture of chemical elements which forms an impure substance that retains the characteristics of metal. An alloy is distinct from an impure metal in that with an alloy, the added elements are well controlled to produce desirable properties, while impure metals such as wrought iron are less controlled but are often considered useful. Alloys are made by mixing two or more elements, at least one of which is a metal. This is usually called the primary metal or base metal, and the name of the metal may also be the name of the alloy. The other constituents may or may not be metals, but when mixed with the molten base, they will be soluble and dissolve into the mixture. The mechanical properties of alloys will be often be quite different from those of its individual constituents. A metal that can be normally very soft, such as aluminium, can be altered by alloying it with another soft metal, such as copper. Although both metals are very soft and ductile, the resulting aluminum alloy will have much greater strength, adding a small amount of non-metallic carbon to iron threads. Its greater ductility for the greater strength of an alloy called steel, due to its very high strength but still substantial toughness and its ability to be greatly altered by heat treatment. Steel is one of the most useful and common alloys in modern use. By adding chromium to the steel, its resistance to the corrosion can be enhanced, creating stainless steel, while adding silicon will alter its electrical characteristics, producing silicon steel. And now, some alloys such as electrum, which is an alloy consisting of silver and gold, occur naturally. Meteorites are sometimes made of naturally occurring alloys of iron and nickel, but are not initiative to the earth. One of the first alloy made by humans was bronze, which is mixture of metals, tin and copper. Bronze was an extremely useful alloy to the ancients because it was much stronger and harder than either of its components. Steel was another common alloy, however, in ancient times it could only be created as an ancient byproduct from the heating of iron ore in fires during the manufacture of iron. Other ancient alloys include pewter, brass, and pig iron. Alloy steels can be made by adding other elements such as chromium, molybdenum, vanadium, or nickel, resulting in alloys such as high manganese are usually alloyed with the most modern steels because its ability to remove unwanted impurities like phosphorus, sulfur, and oxygen, which can have a detrimental effects on the alloy. However, most alloys were not created until the 1900s, such as various aluminium, titanium, nickel, and magnesium. Now, when we go to the 3D part, alloying a metal is done by combining it with one or more other elements. As always, we always know that thing. And now, when unlike pure metals, most alloys do not have a single melting point, but a melting range during which the material is mixture of solid and liquid phases. The temperature at which melting begins is called solidus, and the temperature when melting is just complete is called liquidus. For many alloys, there is a particular alloy proportion called either a eutectic mixture or petractic composition, which gives the alloy a unique and low melting point and no liquid solution slush transition. The use of alloys by humans started with the use of meteoric iron, a naturally occurring alloy of nickel and iron. It is mainly constituent of iron meteorites, which occasionally fall down on Earth from outer space. As no metallurgic processes were used to separate iron from nickel, the alloy was used as it is. Meteoric iron could be forged from a red heat to make objects such as tools, weapons, and nails. In many cultures, it was shaped by cold hammering into knives and arrowheads. They were often used as anvils. Meteoric iron was rare and vulnerable and difficult for ancient people to work. And in the later ages, iron is usually found as iron on Earth, except for one deposit of native iron in Greenland, which was used to Inuit people. Native copper, however, was found worldwide along with silver, gold, and platinum, which were also used to make tools, jewelries, and other objects since Neolithic times. Copper was the hardest of these metals and the most widely distributed. It became one of the most important metals to the ancients. Eventually, ancient civilizations took into account the mixture of the various properties it produced, such as hardness, toughness, and melting point, under various conditions of temperature and work, hardening, developing much of the information contained in the modern alloy phase diagrams. For example, arrowheads from the Chinese Qin dynasty were often constructed with a hard bronze head but a softer bronze stand, combining the alloy to prevent both dulling and breaking during the use. Precious metal alloys. Many ancient civilization alloyed metals are purely aesthetic, pure purpose. In ancient Egypt and other places, gold was often alloyed with copper to produce red gold or iron to produce the bright burgundy gold. Gold was often found alloyed with silver or other metals. Copper was often added to the silver to make the sterling silver, increasing its strength for use in dishes, silverware, and other particular items. Quite often, precious metals were alloyed with the less valuable substance as means to deceive buyers. Now, when we come to the advantages of an alloy, the advantages of alloy differs depending on the specific alloy. Some are better than pure materials, while some are worse. Most of the alloys are certainly used for many purposes. In 1906, precipitation hardening alloys were discovered by Alfred Wilm. Precipitation hardening alloys, such as certain alloys of aluminum, titanium, and copper, are heat treatable alloys that soften when quenched. Although an explanation for the phenomenon was not provided until 1919. Duralium was one of the first edge hardening alloys to be used and was soon followed by many others because they often exhibit a combination of high strength and low weight. These alloys were widely used in many forms of industries, including construction of modern aircrafts. And now, necessity of alloying. It improves hardness, improves wear resistance, corrosion resistance, improves magnetic properties, improves toughness, improves strength, improves machinability, improves hardenability, and improves weldability and hardenability. So friends, this is all about alloy, and my topic is now concluded. Thank you. I take a leave right now.